Okay, so the very first part of this topic is basically fluids, density, and upthrust. So let's talk about fluid first. Suppose we want to. So, fluid is basically a substance that can flow. So, usually fluids can be regarded as liquids or gases, but if solid is made up of really tiny particles, it can act as a fluid as well. Alright, is it clear? Tessie, do you understand this?
Oh yeah, good.
Do you know an example of a solid that can flow? No? Have you seen hourglass?
Any kind of powder.
Yeah, powder. Sand in an hourglass can flow. It's a
Yeah.
solid, Yeah, like that. Okay. So now, before we go forward, I just want to remind you a few things that we've done in our IGCs, right? And basically, we learned about basically mass, we learned about weight, we learned about volume, we learned about density, we learned about pressure. And we're going to use all these things in this chapter as well. So first of all, mass was defined as the amount of particles packed in a body. The symbol of mass was small m. SI units are kgs, and it's basically measured using an electronic balance. Whereas weight can be defined as the gravitational force acting on a mass. The symbol that we use for weight is capital W. The SI units of weight are newtons, and weight can be measured by a spring balance. People also call it the Newton meter. That's the same thing, really. Volume is the space occupied by an object. The symbol for volume we use is V. The SI units for volume is meter cube. And volume has, like, for regular shapes, we got to know the formulas, like say for a square, it's length into length, I mean the cube, length into length into length. Let me write it like this. For a cuboid, it's length into width into height. For a cylinder, this comes often, so you should remember this, pi r square h. And for a sphere, it is 4 by 3 pi r cube. For irregular shapes, basically we use water displacement method. Do you know what that is? Tessie, do you remember water displacement method or no?
It's for volume, yeah?
Yeah. So
Yeah, I do.
so basically you had to measure volume of, you add liquid, you measure the volume from measuring cylinder, then add the irregular shape to get its volume, right? By finding the change in it. Like that.
Yeah, I do.
Okay. Then the most important thing that we need to remember is, and I'm going to write it in a different color, there is also a general formula for this, and the general formula for volume is that volume is equal to area times the length, and that's the third length, okay? That gives us the volume as general, right? Okay, now let me move it a bit on the other side. It's clashing with this. So then density is defined as mass per unit volume. The symbol is rho, slanted P. The SI units of density are kg per meter cube. And the formula of density is that density can be found out by dividing mass over volume, just like that. Now, then we got pressure. Pressure is defined as the force per unit area. The symbol for pressure is small p. The SI units of pressure are pascals. And pressure can be found out using two formulas, generally force over area, or pressure as rho gh. We're going to look at it again. And of course, this is for unit 3 that I'm just telling you a few other things. That for atmospheric pressure, we use mercury barometer, and for difference in pressure, we use mercury manometer. Is everything clear up till now?
Yep.
Okay. Now, I just want to tell you a very, very important thing here. And please do remember this. Sometimes, you have also written this, right? Can I move now?
Oh, yeah, you can.
Okay. So sometimes, you might end up finding the combined density of two materials mixed together, okay? And in this case, remember that there is a correct way of doing this and there is a wrong way in doing this, right? So we're gonna check both of them. So suppose there was a material like this, it had density rho and mass as m, and basically it was added with or combined with another material which had density 2 rho and mass as m2. Now there is a correct way and there is a wrong way of doing this. So I just want to point out so that you don't make a mistake in your exam. The correct way is that first of all you got to find the total mass, and that would be m1 plus m2, and then you got to find the total volume, which is basically v1 plus v2. So the combined density would be m1 plus m2 divided by v1 plus v2, because the formula says density is mass over volume. Do you understand?
Yeah.
Now what most people do is, they're like, okay, they find the density of the first one, they find the density of the second one, and then they add it. So if you do that, basically, the combined density would become m1 over v1 plus m2 over v2. And if you check both the formulas right here, both formulas have a completely different function. So do not make that mistake, okay? Is it clear? You can please write this down. Alright, is it clear? Now,
Yep.
if I ask you to, the question says, find the combined density in terms of rho of above figure. Can you do that?
So we just divide or combine density.
Yep. So I've
So
given
we
you
add
yeah.
the masses and then divide by the total volume.
Yes, but the volume isn't there. So you've got to do something about that.
No idea, actually. Oh, we have to find the volume if one of them isn't there.
Yeah.
Oh, no, we can't. Oh,
You
yeah.
just,
I have no idea.
why do you give up so easily? Can't you just find the values from the given, and find the volume from the given values? Like you would say,
Yeah.
volume 1, can't we write it like, basically density.
It's M1. If three
Yeah.
of them are given, the other one can be found if the combined
Okay, let's see.
thing is given.
Let's see. So this is our formula, right? Okay.
Yeah.
If I want to find the volume of the first material, can I do m1 over rho 1 then?
M1 over there.
Yeah, so we'll get m over rho, right? And if I want to find the volume 2, with that would be m2 over rho 2, and then I can write it
Yeah.
as m, because the mass is the same, or 2 rho. So I get the volume, right? Now,
Yeah.
if I want to find the combined density, like you said, first of all we need to add the masses. So m1 is m, m2 is also m, divided by we add the volumes. What are the volumes?
Yeah.
M over rho.
Well,
Can you solve this now from here? Do you understand what I did?
yeah, I did.
Yeah, okay.
And, my internet so it's slower. Actually. So,
Yeah. It's alright. Reba, how are you?
and it's goodness. My printer stopped working.
It's okay. So we can write this as Ariba, how are you? Why are you late?
Sorry, sir. My guests are here, so I just came to another room right now.
Okay.
That's why.
You come late, Varisha is sick, Safir is sick, Burhan is sick. What do I do? It's sixth season this time. Okay, now. So you can take the basically LCM here. This will be 2m and that's going to be just m, right? Like that.
Yeah.
So then this makes the equation as 2m divided by 3m divided by rho. Now basically this will be multiplied on top, so now you get m and m will cancel out, so basically 2m times 2 rho over 3m, so this is going to be 4 over 3 rho, and that's your answer in terms of rho. Do you understand?
Yep.
So generally expect questions like these. This is from your paper as well, so in the MCQs they might give you a question like this, so you have to understand, you never forget that I have to find the total volume and the total mass to find the combined density. Okay, alright, now let's move ahead. So basically before we go any further, let's first do the derivation of pressure equals to rho gh. Okay, so suppose that we have a tank like this, and of course we got an object that is submerged inside it, and there's like water above it, right, like this. So the object of course has some area on top as well. So we're saying that this part is the area A, and the height is h, and of course on top of it the water is exerting pressure. You guys understand this?
Yep.
And that is because the force is basically equal to the weight of water itself, because the water above has a weight and it's like pushing it down. So first of all we're going to look at the volume of water on top of the box. So that would be, like I said, volume is given by area times the length. That's the general formula. So the volume would be area of the box times the height of the water above it. Is it clear?
Yeah, there is.
Now, in the second step, what we're going to do is we know that the weight of water on top of box will be equal to F. I've called it F, so it's going to be M times G. Because W is basically this is the weight, right? So weight is WmG, W equals to mg, so basically I called it F, so that doesn't matter. The third thing we're gonna do is we're gonna find the pressure on top face. So pressure is given by force per unit area. Now our force was mg, and what we can do about area is, if I write this as volume over the height, would you guys mind it? Can I do that? Can I make A the subject here?
Yeah, you can.
Okay, so then can I say, if I plug that in right here instead of the area, H is being double divided, so it's gonna get multiplied on top, which makes this as mgh over V. Now, if you look at this section only, what is mass per unit volume there? Yes? Do you recall anything? That's pretty bad. Density is mass over volume. Forgot already? Okay. So, can I then say that pressure will be density times acceleration due to gravity and height then of the depth inside the water? Do you guys understand this? Please let me know if you don't. For some reason, somebody's like breaking something, hitting a nail. Oh my god. Anyway, now, is it clear? Tessin, is it clear, Ariba? Any questions? Please let me know. Let me just close the window.
No, sir.
Okay. Now, guys, let me just give me 1 minute. I just need to close the window. Somebody's like, I don't know what they're doing. Let me write it down. Can you hold for a minute, please? Or a second, sorry. Okay. Um, wait a second. Okay, yes, please. Tell me. 058. Okay. 262. 0933. And the country code? Uh, 966. Yeah. Okay. Saudi. Okay. It's fine. All right. Um, Currently, I'm in class, so I forward this to the section, right? Here is my address. All right. So, thank you. Thank you. Class. Okay. So, now, shall we go forward then? Tessin and Reba. Okay. Okay. In 10 minutes, please rejoin the same link. Okay. Tessin, is it clear?
What again?
In 10 minutes, when the meeting ends, you got to rejoin
Okay.
the same link that I sent you. Okay.
Okay.
All right. Now, let's move forward. So, from this point, we're going to learn about something called the upthrust. Now, upthrust is basically a force, okay? And the upthrust is a force, we can define it as a force due to the difference of pressure on a body submerged in a fluid. Okay. However, upthrust basically comes from a principle which is called Archimedes principle. And Archimedes principle basically states that upthrust is equal to the weight of the fluid displaced. Okay, right now you might not understand what I mean, but soon you will. Okay, so just hang on tight. Please write it down. Okay. Now, so suppose that we're looking at body that's completely submerged inside a water body, and there is a object we're looking at like this. Okay. Let me make it on the other side because then I'll have to do the derivation here. So we can say that the height from the top, from the water surface to the top of this box, so let's call this h, height top, and this height from the top of the water surface, from the water surface to the bottom, let's call this h bottom. Is it clear? Now, previously in this equation, what we learned was that basically, number one, pressure only depends on the depth. So, as the depth increases, so does the pressure. Alright. However, it also depends on density and gravity, but when we're talking about the same fluid like water or gas, so basically they stay constant. But the thing we should always remember is that it does not depend on shape, size, color, etc. Okay, so it doesn't really depend on anything except for the depth in the same body, right? Of course, if you put something in a different material and that has a greater density, then of course it would be bigger, but we're talking about the same, so it would stay the constant. Now, which means at the top you're gonna have less pressure than at the bottom. The why? Because the depth at the top is less than the depth at the bottom. So this is, say, the pressure at top, and then at the bottom the pressure is going to be larger. So I'm just trying to make it like these arrows bigger, just to signify that it's like this. Okay, all right. Now on this, so this is the pressure on bottom. On the sides, something really interesting happens. So on the sides, because there is a gradual increase in pressure, so the sides experience higher pressure. It keeps on going like this. Okay. Similarly, on the other side, it would behave the same way because the depth is increasing at every point, and it would basically show you an increase like this, right? The sides don't matter, and the reason it doesn't matter is because of the fact that the reason it doesn't matter because of the fact that they both have equal pressure on the sides, so it increases equally, but there's a difference of pressure on top and bottom. Is it clear, Tessim?
Yep, it's clear.
Okay, so now let's move towards the derivation of upthrust and proving that whatever Archimedes has said, whether it's correct or not. So first of all, we're going to look at, they're seen in about 2 minutes, meeting will end, so do remember to rejoin. Okay, so the pressure difference will be delta P, and it will be pressure at the bottom minus pressure at the top. Because of this, of course, this object will feel force on top, and it would feel a larger force at the bottom because of the difference in pressure as well. So what you can do is you can write pressure as rho g h top minus rho g h bottom, and I just want to tell you this rho is the density of whatever the liquid is. Currently we're taking it as water. Now, so then if I take the density as common, so I'm going to get h top minus h bottom, which basically gives me the difference in pressure is due to the difference in the height between these 2 points, which is basically this point all together. Is it clear? That's the dimension of the object itself. Understood?
Yep.
Okay, now look at this. So we have also learned that pressure is given by force per unit area. So the force is basically, the net force is basically force at bottom minus force at top, and the area is the same. So we can say it's basically the difference of force between them is causing it. So that's the resultant force here as A. Then what we're going to do is, we know that this pressure is equivalent to, basically this is pressure, and the other equation of pressure is rho g delta H that we just found on top, right? So I basically Okay, my bad, sorry. Now, so basically what I did was I equated this to this. Do you understand this thing? Both are pressures, right? That's fine. So then I could say that this difference in force, if I multiply A there, so it is going to be rho G delta H times A. Can I do that?
Yeah.
What exactly is height and the area? This is basically the volume of object, and because of this volume, it is also equivalent to the volume of fluid displaced. Displaced means that when you add something, it takes up the volume of the fluid itself. So that is displaced and it is equal to the object volume. Do you understand now? So then I can basically write it as delta F is rho G equals to delta V. And now check this out, please. This force that you found out is basically the upthrust, and we learned that basically upthrust comes from the difference of pressure. That's the definition of upthrust. And upthrust is generally given by U, and the formula for upthrust is rho G delta V. So I'm just going to write the things here so you remember this. So this is the upthrust, which is a force. This is the density of fluid. This is basically the acceleration due to gravity, and this is the volume of object submerged, or you could say volume of fluid displaced. It is the same thing. Is it clear? Any questions up till now? All right. Now, from this point onwards, what we can do is we can prove Archimedes' principle. Have you written this, Tessin? Should I go up?
Yeah, but
Okay. So Tessin, if you go back and recall what Archimedes said, so we have just done upthrust, which says it is the force due to difference of pressure. We do understand that. But now Archimedes says that upthrust is equal to the weight of the fluid displaced. And if it is the weight of the fluid that was displaced, how so? Because if you just write the equation again, delta H, delta V, my bad. So you might realize that actually, can I write it as rho times delta V as together times G? Can I do that?
yeah,
Now check this out. Density would be mass of the fluid divided by the volume of the fluid displaced, right? So if I divide this, if I multiply this, so mass of the fluid will become equal to density times the volume of fluid. Can I say that? So then
yeah,
basically I can replace this mass right here. So that would make upthrust be mass times gravity, which is basically the weight. Mg is the weight of fluid displaced, and that's what Archimedes has suggested. Understood? Okay, do let me know if you have a question now. Interesting. Now, okay. So for today, let's keep it till here, because then you will be overwhelmed. But I hope you understand everything that I've taught you today, and let me know if you have any questions before I close the class.
Okay. Sir,
Yes, Tessie.
weight is equal to upthrust in formula, yeah?
Weight is equal. No, this is the weight of the fluid that was displaced because of the object that you submerged in it. It's not the
Oh
whole
no,
fluid.
because in my school, yeah,
Okay.
my physics teacher said when deriving, say weight is mg, yeah,
Yeah.
and mg is equal to upthrust
Yeah,
as
but
well.
well,
Oh, okay, yeah, no, it makes sense.
well, he must have told you that it's the weight of the displaced fluid only, not the whole fluid.
Yeah,
Yeah.
that's
So
right.
yeah. So I also wrote it, but that's what you need to understand is the concept behind it, right? The concept is it's only dependent on whatever the object. When you submerge an object, you find its volume. That is the volume of the fluid that was displaced because of it. And then if you find the weight of only that particular volume of the water, that is the upthrust. Understood?
Okay.
Yeah. Is everything clear now?
Yep.
Okay. So I hope to see you. I hope to see you tomorrow. But
Yeah.
do give feedback to the academy so they know whether you're coming in or not
Okay.
tomorrow. Okay.
Okay.